There's been quite some discussion about this photo taken from Hoylake, exactly what all these lights are and what are we seeing in the photo. And I've analyzed this once before. Now recently I was in a hangout where someone suggested perhaps this photo was actually taken from Southport, not from Hoylake. And one of the things which I mentioned in the comments afterwards, during the video, during the hangout and the comments afterwards, is that if it was taken from Southport, we're missing quite a few features. We're missing the ice blast. We're missing the big one. So this couldn't have been taken from Southport. Now, I can prove it was actually taken from Hoylake by matching it up with the lines of sight. So these are the lines of sight from Hoylake to all the different items we're looking at. So one of them is the big one, the roller coaster. The other one is the ice blast, which is this one, the blue one. These two white ones go to a ride on South Pier, which is the skyscraper ride. This red line goes to the tower, and the pink line goes to the heart on the tower. And this one over here goes to a radio mast, which someone suggested might be the light on the right. So if we align all the lines of sight, you can see that it matches perfectly. Here's the line of sight to the Blackpool Tower. Here's the line of sight to the heart. Here's the line of sight to the skyscraper rides on South Pier. Here's the line of sight to the big one, roller coaster, and here's the line of sight to the ice blast. This is the line of sight to the radio mast, and you can see it doesn't match. So I stand with my analysis. So this is the ice blast. And I can prove it in another way. One of the things that we discussed in the hangout last night was that we actually know how big this field of view of this photo. We can work out the field of view based on the metadata on how much the picture was zoomed in. It was actually 1.1 degrees of arc between here and here, from right to the left. And we can figure out how many degrees of arc is between these objects. So first of all, Blackpool Tower is 9.76 degrees azimuth from the view in Hoylake. The big one is 10.26 degrees of azimuth. The ice blast is 10.35 degrees of azimuth. So the difference between Blackpool Tower and the big one is 0.50 degrees. And the difference between Blackpool Tower and the ice blast is 0.59 degrees. Now I measured it with a ruler. So 10 will correspond to 1 degree and 11 corresponds to 1.1 degree. Now taking the same scale ruler and place the 0 on Blackpool Tower, and we can see the big one falls on the 5, which is 0.5 of a degree, half a degree. And the ice blast falls on the 0.59, which is exactly what I show here. With this analysis, we can show that my original analysis was correct. Now this slide might look a bit busy, but I'm going to analyze how much of the tower we can see and how much should we see. Now first of all, this is the picture that was taken at night from Hoylake, and the picture was taken on April 29th, 9:39. The person was 27 feet high. The distance is 29.2 miles. Now, one of the things we have to know is that if you look up the tides on that night, at that time it was almost low, very, very low tide. The tides in this area are massive. There's about 30 feet of tides from high tide to low tide, spring tide. So because it was low tide, you have to add about 15 feet to observer height and to the tower to your calculator. So if you go to the calculator and you put all these numbers in, you find out these 4 different figures. So the purple figures is with no refraction, and the yellow figures is with standard refraction. So let's first of all see. So with no refraction at mid-tide, 347 feet. So if you look on the ruler, I've measured it out. 347 feet is this line here. This is how much of the tower should be visible if it's normal tide and no refraction at all. This is the now low tide, 301. So I've put it on the ruler here. Standard refraction mid-tide is this one, 284, so that's on this ruler, and low tide with standard refraction is 243, as you can see here. Now, how much of the tower we can actually see? I believe we can see till about here at the nighttime photo. So we have slightly more visible in the nighttime photo when it's standard refraction and low tide. So all it can mean is that we had a slightly more tide, or it could mean that we had slightly more refraction. It's not a big deal. It's very small amounts discrepancy. Now, this is a photo taken from the same location, but during the day. And over here, we can see the horizon is much higher up, about just under 300 feet is missing. So what I want flat earthers to explain is why all this is missing. All right, why is all this missing in the daytime photo? What I want, we just have to explain this amount. That is between low tide and standard refraction, and what we actually see is a very, very small amount discrepancy. And what no refraction and normal tide will show over here. If you just take refraction and mid-tide, which this photo was taken probably a couple of hours before this photo, so we have the metadata for this. This picture, we don't have the metadata, so the exact time is not available. But if we say it's about mid-tide with standard refraction, it fits perfectly. So the night photo, all you have to know is we were at low tide, standard refraction fits almost perfectly, and the daytime photo, standard refraction fits perfectly. So it's quite understandable why we see so much of the tower over here and so little of the tower over here, because of tide. Tide has a huge effect. And the other thing is that nighttime we often get more refraction than during the day, because refraction, cold air, causes more refraction than warm air. So everything is explained according to um, the curvature of the world, curvature of the globe. What flat earthers have to explain is why so much of the tower is missing here in the daytime photo and so much of the tower is missing in the nighttime photo. Finally, flat earthers need to explain why we're missing so much in our photo. Everything from here, all this should be in view. So all this should be in view. We should see this pier, the entire pier, not just the tips of this ride here. We should see all of this street here, and we should definitely see his Ferris wheel. This is quite tall. Why can't we see it? All this is lit up at night. Why can't we see it? All this is lit up. Why can't we see it? All these will be in the photo, but we can't see it because it's behind the curve. Only very tall structures like Blackpool Tower or the Ice Blast or the big one, those can be seen because they're quite tall. But the other things that are not tall enough will not be seen. Flat earthers need to explain why so much of Blackpool is missing. It's missing because it's behind the curve. Flat earthers don't have any explanation that is coherent.